Number 23 in section 2.7 is a problem I tried to prepare you guys for with something in our notes. This is one that requires what we called fuzzy math, everybody. And fuzzy math only is relevant when you're doing a limit as x approaches infinity. This would not be applicable, not the method you would use, if x was approaching a finite number like 0 or 2 or -7. But since we're only concerned with really big values of x here, we can ignore, or the word is neglect, certain terms that matter when x is small, but are really insignificant when x is big. What terms are those? This 1 right here, this 2, and this 3x. Those are what we call negligible terms. And all we really care about are the highest degree terms in both the numerator and the denominator. So this limit, guys, is equivalent to the limit as x approaches infinity of, still need to worry about the square root here of 9x to the 4th, and the denominator is 4x cubed. Now I want to be loud and clear with you guys. This statement that I just made, and really this should probably come at the end of that line right there, hopefully you see that, this statement would not be correct if the limit wasn't there. In no way, shape, or form am I telling you guys that this and this are exactly the same thing. They do not return the same value for all input values of x. But since this is a limit question, we're not really dealing with all the exact details of each particular one. We only care about what happens when x gets really big, so these three terms then can be kind of sacrificed, I guess. They can be neglected. And these two limits are the same. So we can clean up that numerator just a little bit right there, and you'll notice this is not a coincidence. The radicand that we're left with, 9x to the 4th, is a perfect square. And the square root of 9x to the 4th becomes 3x squared all over a 4x cubed. So now this is a straightforward rational function. So we compare degrees of the numerator and denominator. A 2 on top and a 3 on bottom means that our horizontal asymptote, or our limit as x approaches either positive or negative infinity, is going to be 0 in this case, anytime the degree of the numerator is less than the degree of the denominator. So fuzzy math allows you to kind of ignore those negligible terms and just focus on the highest degree terms on both parts, which is only applicable because it's a limit as x approaches infinity.